we're going to have a look at what we can do when we've got some trig that looks like this. Some sines, plus or minus, some coses, perhaps equals something. At AS, you would have probably thought straight away divide through by cos x, because that will get rid of that and you'll just be left with some tans. Sin x over cos x is tan, minus 5, cos x over cos x is just 1. But now we know that we're going to get 8 over cos x, which can be written as 8 sec x on the right hand side. At AS, this would have usually been equal to 0, therefore we wouldn't have had a problem here. At A2 though, this will present a problem. It doesn't equal 0, and therefore by dividing through by cos we haven't got it down to just one trig function. So we need another technique. We're going to choose to write this in the form r sine x minus alpha. I'll explain my exact choice of this particular function in a moment, but first of all we're just going to expand this using our compound angle formulae to see what we get, and then we'll look for the similarities between what we see and what we have and see how it can be used. So expanding this, we're going to get r cos alpha sine x minus r sine alpha cos x. Okay, looking at this, we can see that it's of the right form, and that's what we're really interested in. It's some sine x's minus some cos x's. That's the form we have. What I also noticed then is that because I want this to be literally the same, I want it to be an identity, I want this to be exactly the same as that, I know that the coefficient r cos alpha, well, that must be my 12. I know the coefficient of sine x must be 12. Similarly, I can see here that I know that I must have 5 cos x's, because in both cases, because it's an identity, I want to be subtracting 5 cos x's. So I also know that our sine alpha must be 5. Okay, we can now draw ourselves a quick little triangle. Sometimes this helps people, with a hypotenuse of r, an adjacent of 12, and an opposite of 5. Remember, when you have hypotenuse times sine alpha, that will equal your opposite. Hypotenuse times cos alpha, that will equal your adjacent. We can now use a quick bit of Pythag to figure out that r squared is equal to 12 squared plus 5 squared, meaning that r is 13. And we can now also find tan of alpha. That's going to be 5 over 12. So if I just do inverse tan of alpha, that will give me my angle. I'll just run and get my calculator very quickly. There you go, nice professional job, fully prepared as always. Okay, so that gives us an angle of 22.62 degrees. Okay, always check if the question's in radians or degrees, you don't want to work in the wrong one at this stage. So that tells us that we can replace 12 sine x minus 5 cos x with 13 lots of sine x minus 22.62. You can now solve this, ignoring all the work we've done up to that point, so I can ignore all of that. I'm now faced with simply solving 8 equals 13 sine x minus 22.62. Simple AS question, I can solve that over some domain that I'm given in the question. Okay, final thing that we're going to discuss is why did I choose the form r sine x minus alpha? Why did I not choose r sine x plus alpha or r cos x plus or minus alpha? Well, let's just look at what that expands to in each case. We've already seen this one. This one would give us exactly the same, except that sign would change to a plus. And this one would give us r cos alpha cos x minus or plus. Let's just do it in a slightly different colour so it's easier to see. Remember, the convention is if you were using the bottom one here, you'll be using the bottom one here. We'll colour code it just to make that a bit clearer. Okay, so we can see that when I look at this first form, I do indeed have some sines minus some coses, some sine x's minus some cos x's. That's the form we wanted. All depends on that sign there. Okay. If we'd have chosen plus alpha, that would have been a positive sign. Not what we wanted. We wanted to be subtracting our cos x's. And finally, if we'd chosen the cos form, we would have either had them both as positive or we would have had negative sine x's. We can fix these problems by clever choice of the angle alpha or r, but it's generally easier if you pick the nicest form. You can just use the value of alpha that you get from your calculator. You don't need to worry about changing it so that sine's negative, cos is positive, or vice versa. Choosing the best form makes your life easy. You've got the formula books, but you should be using these so often you just remember what the forms are, look at what you've got, and choose the most appropriate form. Anytime you've got some sines, some coses, and you want to combine them into one, this is a method we're going to use. R, sine or cos, x plus alpha. Okay.